Hello everybody and welcome back. This is a hard problem on LeetCode, expression add operators. And we'll get to why that is hard because it involves a number of layers that needed to be peeled out for you to actually get to the solution. The problem becomes slightly easier if you're doing it in Python because Python has access to this one special sneaky function that can make your life easier. But if you're coding it in Java, C or C++, I'm not aware of any of those. So what if you're coding in those languages? Even if you use the Python sneaky function, an interviewer in this question may ask you, you know what, you use that function? That's great, but can you implement it yourself? And so today we'll take a deep dive into this problem. Okay, first things first, let's clear out the input-output format and we can get started. Okay, so you're given two pieces of information, num and target. And you have to return the list of possibilities inside of nums that matches the target. What I mean by that is, let's take an example. We have num equals to 1, 2, 3, which is a string of digits, only digits, and you're given another input as target. The goal of this problem is to return this answer string, this answer list of strings, which contain these sort of modified strings, which is going to be 1 plus 2 plus 3 and 1 times 2 times 3. What it means is you want to somehow manipulate and add operators in between of this nums string, and you have to modify this string in such a way that you can get to the target. So by evaluating 1 plus 2 plus 3, you can get to 6. Also, if you evaluate 1 times 2 times 3, you will also get to 6. The question basically says that you have access to 3 operators, star, plus, and minus. Star lets you multiply, plus lets you add, and minus lets you subtract. And using these 3 operators, you have to somehow insert these operators inside of this num thing that can get you to the target. Now, life would be quite simple if it was only restricted to digits. But let's look at another example where that is no longer the case. In the case of 105 as num and target as 5, we see two cases. 1 times 0 plus 5, which is 0 plus 5 over here, which is just 5. Fine. But we also have a case of 10 minus 5, which evaluates to 5, sure, but 10 is nowhere given in this question till you realize that it's just a concatenation of 1 and 0. And this is one very important observation for this question. You can concatenate. See, the question only gives you this plus, this star, and this minus thing as operators, but it's sneaky in that you can also have this concatenation operator as a fourth. Right? So we have 4 operators in our hand now, and we have to somehow insert inside of this nums thing to get to the target. Let's formalize this and we'll get to the brute force solution. So we have 4 operators, plus, addition, minus, subtraction, star multiplication, and dot as concatenation. One very important thing to note is that this concatenation always is like we have 105 as 1 and 0. So you can always have 1 and then 0, but not 0, 1. Concatenation only lets you do it in a certain order and does not let you flip this. That's going to make our life easier later on. Anyways, so we have 4 operators and we can insert them. We can insert these operators anywhere between the digits. So let's say that we have 5 digits in total. And so we can have 1, 2, 3, 4 spaces. In other words, if you have 5 or n as the total length of this given string, you can have n minus 1 total spaces in between them where you can insert these operators. Now you can have n minus 1 spaces and 4 operators for each of these guys to go into. What this means is a time complexity of order of 4 to the power n minus 1 if you want to enumerate every single case. This is already big, but actually if we look at the constraints, I'll show you here, we are given the nums length to be less than equals to 10. And since we are going for, since we're going for n minus 1, that is well below the range of, what may give us time limit error. So we are safe and we can say that even the brute force solution of enumerating every single possible case is going to give us the answer. But I still have not yet talked about how do you evaluate the expression. Because even if you have these 4 to the power n minus 1 strings enumerated, somehow you can enumerate them, we'll get to that very soon, but you still need to evaluate them. And this evaluation part is where the Python sneaky function will come in. And we'll talk about it later on, how we can write it actually manually, and that would apply to all other languages as well. Anyways, this is something to explore later on, but first we want to enumerate and brute force it. So we'll brute force every single possible case. And for that, I'm going to use recursion. Okay, so recursion will take input as 2 items. First is the I, the index of what current element you want to look at. Is it x1 or x2 or x3 or x4 or x5? I want to know where you want to, on what digit you want to consider. So I will give me that information. And S is whatever happened beforehand. So S will sort of contain all of the string that we brute forced up till now, right? And so we can enumerate harder and we can sort of take that string, 4 of these combinations appended to all of the strings here. And so we'll have 4 times whatever we had previously. It's a bit more to take in, but yeah, that's basically what we're doing. We have input as I, S. The recursion doesn't really return anything, so we can just leave it blank. It's a void type. And we want to store all of those S's at the very end, by the way. We want to store all of those strings which matches the target. We'll use, again, evaluate for, like, this is something for later, but we're going to keep that as is for now. And we'll store all of those S's which matches the target. And the way you can generate more cases for the future is by using those 4 operators. And this concludes the first part of the solution. We'll actually want to code this up because the second part relies on the coded part for the first one. So we want to have a recursion function. So we'll have I, S as we discussed. And the base case is saying that, if I is greater than n, or actually I should call it n minus 1. If I is greater than n minus 1, which means we have exhausted everything, I'm going to return. I'm going to do some more computation here, but I'm going to return basically. And we'll do some more computation here, which is the sort of base of this recursion. We can also start this recursion by saying that, where do we start this recursion? I will be 0 and S will be an empty string. We can do that, but the structure we're going to follow, and this is just an implementation detail, I'm going to initialize it with num of 0. Because I'm going to keep the first thing as the character, first thing as the first digit. I'll show you here. So I'm going to keep the first one as x1. And then what I'm going to do is I'm going to take this underscore xi and we'll just loop it all the way across. So you can see that that is pretty consistent. You can also try an implementation where you take this guy, x1 underscore, and basically you can go all the way up till the end and you can consider this case separately. I prefer to do it this way because it's more convenient. Okay, so we'll start off with the first character, split it out, like we'll just handle it individually earlier on, and then we'll not have to worry about it later. Okay, we recurse, we also want the information of n as the length of num. And we also want to have this answer list, which is going to store all of the possible answers. This recursion, by the way, is going to get a bit complicated in just a second. So this is a fun question, that's why. But anyways, we'll return whatever answer we get over here. So once we're done with the recursion, we're done with the question. In here, now we're looking at the very end. We're looking at the very, very end where we have this S string with us now. Now look back at this point. We want to store all of those strings which matches the target. So we'll go ahead and implement that. So if evaluation of S is the same as target, then I want you to store this in the answer list. And that's it. Again, this evaluate function we're going to explore very shortly, but let's just have one sort of running version with us so we can iterate on it. Now in the recursion, now we actually want to talk about the solid 4 things we want to generate. In this case, we want to iterate over every single of these 4 operations and generate all of the possible cases. Let's do that. So I have recurse, and we'll start from I plus 1. I'll just copy paste this name. Okay. We'll start from I+1 and we'll say, you know what, we had this S string before, but now I want to have this plus character to it, and we'll access the num of I, which is going to give me the current element, the current digit I want to append. And we can just copy pasta and we're done with plus, minus, and star. Oh, and similarly for, give me a second. Yes, cool. Okay, and similarly for nothing is the concatenation operator. So we can just do s plus num. So this is concat, this is plus, this is minus, and this is star. Pretty easy, pretty trivial, right? But this won't work. It's a very good reason why it won't work. And if you're familiar with these sort of questions, you'll immediately realize why. See, when we write concatenation is the key of all of the issues we're having. When we write concatenation, we can have a case like 105. So we'll take 105, and inside of that, we can have say 1 plus 05. This is not a valid number. 05 is not considered a valid number. In fact, if you try this out, eval will throw an error saying that, you know what, you can have 00, but you can't have 05. That is not allowed. That's because it represents the octal number system instead of the decimal, which we are going to work in. Google them if you are unfamiliar. Anyways, this means that we don't want to have these zeros in leading places, but nowhere in my recursion have I checked for leading numbers. So we'll actually have to add one more variable for this. I'm sorry, I know this is going to get complicated very soon, but we want to have this another piece of information going in which says that, you know what, there is a leading element, there is a number. So again, in this case, we can have sort of 100 case. We can have a number like 100, not because there are multiple zeros in 100, but because there is one leading all of these zeros. You can also have 1500 or how many zeros you want, but you cannot have 005. Make sense? You can't have leading ones. No, sorry. You can't have leading zeros, but you can have leading any other character. So somehow we want to have this condition saying that, you know what, if leading is not equals to 0, only then go ahead and recurse this guy. So we want to have this information of leading. We'll actually go ahead and implement and add this to the recursion as well. So we'll have leading initially as num of 0 itself. And for now, we'll have leading over here. Now, how does leading change when it's in plus case? When we have encountered a plus, it's basically saying that, you know what, I'm starting a new number. So the new number will also have a new leading digit. And with what is going to be its new leading digit? After plus, I'm going to start with num of I. So num of I itself is going to be the leading digit. So we'll just pass num of I as the extra piece of information. And we'll do the same for all of these cases over here. In case where we have this sort of tricky concatenation case, we want to ensure that we are not passing num of I. This will screw up everything and will nullify the existence of leading. What we instead want to do is put leading as well. This is basically saying whatever was leading before is still leading if you're concatenating. If you are instead doing plus, minus, or star, we'll restart or refresh the leading digit. And I'll do a quick sanity check because this should work at this point. Okay, this looks like it is not working. Cool. Oh my god. Is there a very dumb error hidden here? Oh no. Okay, so what you want to do is you want to start the recursion from 1 instead of 0 because you've already considered 0 over here. Man, that is stupid. Okay, cool. It works and we can submit this over here. Let me just clean this up and we'll talk about the second part where we'll write this evaluation function on our own. Okay, cool. So the first thing we want to know while evaluating is there are two parts to this, okay? The first is tokenizing and the second is actually calculating the evaluation. Okay, let's talk about the first part. The first part is saying that, you know what, you have all of these strings. Let's say it's the case of 12 plus 4 times 7 minus 81. We already understood that it is we have this concatenation operator. So 1 concat 2 became 12 instead of 1 2. And we'll have to now consider 12 as its own separate entity. Similarly, plus is its own entity, 4 is its own entity, star, 7, minus, and 81. So we have all of these list of entities that we now need to consider separately. If we can split this original string s into these guys, then maybe it will be easier to evaluate. So the first step is actually going to do tokenization. Okay, we'll call this array A and we'll store all of the answers here. We'll iterate over all the characters in the given string. And for each of the characters, now we ask the question, is it a character? Is the character a digit or not? So we'll say if it is between 0 and 9, we'll do some computation, otherwise we'll do something else. If it is a character between 0 and 9, it may be part of a longer character. It may be a part of longer number. Let's say we encounter 2. Now 2 may just be a part of all of those that came before it. In this case, it's 1. We somehow need to have this temporary string that can hold all of this information. So we'll create a temporary string, temp equals to this. And in here, I'm going to do temp plus equals to C. This will be just adding all of these characters. As I encounter characters, just going to append those to the temp. So I encounter 1, I'll add it to the temp. I encounter 2, I'll add it to the temp. What if I encounter a plus though? This means that this temp has ended. Like we have considered 12 as the entire number now, and we want to somehow store this information. So we'll a.append the integer value of temp. We have this temp in our hand. We have the number 12 in our hand. Once we have that number in our hand, what do we have next? We have plus, right? Plus was the character that said, okay, you know what? 12 is done. Now consider me. So we'll consider plus as well. We'll consider plus. And the next thing we want to do is restart this 4. Okay, so the temp originally was an empty string. We added 1, we added 2. It became 12, then we encountered plus, and now our request is save the 12, save the 1, save the plus, sorry, and then restart the temp. So we'll restart the temp over here. Okay, so cool, we're done with the tokenization part. Almost done. There's one last thing that remains. You'll also have this 81 at the end. And remember, the only time we're sort of clearing out this temp is when we encounter a symbol. After 81, there is no symbol. So we somehow also need to store the 81 itself. 81 is still inside of temp, has not been stored yet. So we'll do a.append temp. I know this part is a bit complicated, but I think it's the best thing to do is just write down and see for yourself what happens. Take an example like this one, pause right here and figure it out yourself. And you'll see the working of temp, the importance of temp, and how we're adding these to the A list. Now we'll come on to the second part, which is the evaluation part. Okay, evaluation is a bit complicated. We'll start off with the total. And I'm going to start off with A of 0. See, we have 12 in our hand as starting from the total. And each time I'm going to encounter a symbol, I'm going to say, you know what, if it's plus, then go ahead and add 4 to it. Add the next element to it. If it's star, then I'll say, take the star and whatever is the next element, add it to the previous one or use it with the previous one. Okay, I think it's best to also show this in happening like, so I'll just put it here and we'll do some computation here. So I'll say, you know what, if A of I is a plus, then what do we want to do? If the current element you're looking at is a plus, then that means that whatever total you already had is now going to be total, whatever you already had, plus the A of I plus 1, whatever you have in the future. In this case, A of 0 is 12. Okay, A of 0 is stored in total. We have 12 as the answer in our hand right now. We have only 12. we encounter plus, we'll say, you know what, plus means that we want to add some element to 12. We want to add the next element to 12. And so we have done exactly just that. We have said total equals to total plus the future element. Similarly, we can do this for minus as well as multiplication. So just copy paste and editing, easy peasy, and this, and then we're done. We can just return total. If you try this out, you'll realize that there's a big issue hidden here. Pause and try to figure out if you can, but I'm going to spoil it now. Let's take a look at two examples and we'll see what's going wrong. We have, say, 2 plus 4 times 3. So we'll look at 2 as the total right now. And this is what we're going to start with. Then we encounter plus, and so plus means that we want to add the next element 4 to the previous element 2. So the entire computation is now 2 plus 4, which is 6. And so now we have 6 times 3, right? It's total times a of I plus 1. This is clearly incorrect, right? We only want it to be multiplied with the previous element. So wait a second. Okay, I'll show you another issue and how to fix it actually. So we only want to multiply 3 with 4, right? We somehow have this extra 4 hanging out in here. So what I'm trying to say is 3 should have been multiplied with 4, 4 should have been multiplied with 3, but it instead got added to 2. So 3 says, you know what, I am higher priority, I want 4, so I'll get 4, but 2 does not get 4 anymore. So we'll actually take away 4 from 2, saying that I'm going to take away previous element from the total, and then I'm going to add previous element times this guy. What I'm saying is, we have 2 plus 4 times 3. 2 plus 4 became 6 times 3, but multiplying says that, you know what, that is not going to work. What I'm going to do is I'm going to steal 4 away from 2. So 2 plus 4, which was 6, is now going to be 6 minus 4. I'm going to steal 4 from this guy, and I'm going to give it to this guy. I'm going to give it to 3. So it's now 6 minus 4 plus 4 times 3, or total minus previous plus previous times the next element. Total minus previous plus previous minus the next element. One last thing to know is what is previous. So we'll actually have to initialize previous separately. Hello. Okay, so we'll start the previous from a of 0 as well. And each time we add this future element, we are also going to set the previous element. Okay, so the previous element in this case is now going to be updated to a of I plus 1. In this case, it's going to be minus of a of I plus 1. And in this case, it's going to be previous of a of I plus 1, but also previous into, because we also keep this updated with the previous ones. Are we done finally? Okay, also we're expecting to do a I plus 1, so we'll have to do this minus 1 over here, unless, like, if we don't do it, it will just go out of bounds. I want to test this out first. I'm very scared. Okay. An error between int and string. Okay, so the total is cool. I'll take a quick break and figure this out. Okay, so I figured out the error. I did not do int of temp here. I just did temp here, which meant that I'm not actually considering the integer version of, in this case, 81 over here, but the string version, which is what gave me the error. Oh my god. So we'll finally submit this guy, and hopefully this works out well. So we already discussed the time complexity, which is going to be 4 to the power of n minus 1. Okay, great, accepted. And I'm very sure the space complexity is around that, because the worst case could be that we have to store every single possible case of everything we enumerated. We may have to store every single thing. So that may take order of 4 to the power n minus 1 as well. Not exactly sure about this part. Maybe there's a proof out there. Let me know in the comments below if you find something. Anyways, this is the long convoluted explanation for the problem expression add operators. And as always, thanks for watching.